Hello, today we will learn about the flow simulation and we will do simple fluid simulation by using Ansys Fluent solver. First of all, we need to build a geometry that the flow will flow in it or in it. So let's first open SolidWorks and we will design a shape to do simulation on it in Ansys. Just wait a minute. Flow simulation. Ansys has two most popular flow simulation solvers: Ansys Fluent and Ansys CFX. Each one of them has its potentials and field of use. So now SolidWorks is ready. We will design a shape. Let's be simple. Let's first make a circle. Okay, let's be 50. Okay, now we will do extrude. Let's be 25 millimeter. Then we need to do some holes on this geometry. So I will sketch a hole right here. Let's be 5. Okay, now I will do circular mirror or circular sketch pattern. Let's be 5, 6. Okay, and do extrude cut. Let's be through all. Okay, now I will do more walls. This will also be 5 and do a circular pattern. Okay, that's good. Now we will do extrude cut and make it through all. Good. Now we will edit the materials. Be steel SI 1020. Now I will save the geometry to open it in Ansys. Part 2. Okay. Now I will open it in Ansys Workbench, Tools, Ansys Workbench. Okay, let's close SolidWorks to have more resources on this computer. Okay, now I will open the geometry using design modular. It's Ansys solver that used to design, but it's not so good, so a few of designers using it. Okay, okay, after it will open, we have to do now I need to take generate. Now after it's generating it, this will take a while. Okay, now I need to add enclosure from tools. I select enclosure. This will generate a tube or a tunnel. Let's make the shape of it a cylinder, because this geometry is fixed as a cylinder, and the plane, let's be z-axis. It have to be z-axis, not automatic. Okay, z-axis, depending on my general coordinate system, it must be like this. Then I will make it uniform, and let's be 0.5 meter, and I will generate. It's too big, so it's too big, so I need to make it smaller until I find the appropriate one. Also, let's be 0.15. Okay, that's good. Let's say 0.1. Okay. I think this is good. Okay, this is good. Now I need to make a boolean to distinguish between this face and this face. To make this face, for example, an inlet, and this face the outlet of the tunnel, because I will need it later in the Ansys workbench. So I will search for a boolean, create variable version for a boolean, and now I have to select the target body. Okay, now I will tool body, let's say this, and now I need to create a boolean as I say. So operation subtract, and target body, this is the target body, and I say apply, and I need the target body and the tool body. I will select this body. No, it's not being selected. I will select solid. Okay, and tool body is this, and okay. Now I have two parts. Part 1 is geometry, and part 2 is the outside shape. Okay, this is good. Now I need to save it. Okay, now I need to save it. Boolean generate. Okay, it's been generated. Okay. Now I will save. Fluent, let's say, and make a save. Now I will choose the solver. It's Fluent and the sharing about geometry. Now I will double click on the mesh and put start mechanical. It's starting right now. Okay, it's starting. Okay, now I will go to the mesh and go to the mesh, go to the sizing and make it fine. And now I don't have to do a lot of things. I just will make generating a mesh. Now it's making mesh for the two bodies. Okay, I can see the inside by clicking on no, not this. It's okay. Now I see the mesh for the inside body and the outside, as we see, and this mesh are the nodes that will be solved for this equation. If I go to statistics, I will see the number of nodes, the number of elements, and mesh metric. Okay, now the next step is to define where is the inlet, the outlet, and these things. Okay, now if I make a cut, for example right here, I will see the number of meshes, the holes, how they are meshed, and a lot of things. So I will delete it. Okay, and I will go to influence information options and make it smooth transaction. Okay, now I need to select just insert or what are called cursor mode face insert. Okay, not insert, it's space, create name selection, it's inlet, and this side will be outlet. Okay, so this is the inlet, this is the outlet, and this will be fluid. Okay, and update. Now it's updated. This is the name selection, this is the inlet, this is the outlet, and this is the fluid. Okay, that's good. And this is the mesh. And now I end from the modular. I will go to model. So I will close this and go. What is the problem? Okay, I now will open Fluent Launcher. This here I choose if it is 3D or 2D. As we know, the design is 3D, so I click OK. Now the solver will open Fluent. Now I need to set up the material, and the cool thing about Ansys 2016 release is that all the necessary steps for the analysis is categorized here. So all you do is select each one by one of these options, and you will be ready until you go to the results. But in the previous releases it was so difficult because there is no steps right here, and you should go from menu to one and for another and go back to the other one, and it was so difficult. So the first thing is we will do a check, and checking mesh, it's done, but we can do more refinement by making the target 0.85 for example, and then do a check. It's better convergence. Now we will go to models. We will do we can choose from multiphysics, energy, viscous, laminar, radiation, heat exchange. We want viscous laminar, and we will choose K epsilon equation, the second equation. Every one of these methods or models have its benefits and defects. For this example, K epsilon is good for linearization. Okay, now we want to add a new material, for example liquid. So we have here vapor liquid and water liquid. So I'm choosing the water liquid. R is the specific heat, density, thermal conductivity and viscosity, the material specification. So I make it copy. Now if I go to cell zone conditions, I need to choose water liquid from here. Okay, now if I go to boundary condition and I choose inlet and edit, it's a velocity inlet, so I will make it 2 meter per second, and the initial gauge pressure in Pascal is be 300,000. Okay, now I will choose the specification method. Let's be intensity and hydraulic diameter. Turbulence, let's be 0.3, and hydraulic diameter to be 0.03. Okay, and for the output let's make the same. The gauge pressure 300,000, intensity 0.3 and 0.03. Okay, Now I'm going to save only each only modified. Okay, now this is the reference values for inlet. This is the values I choose. Okay, solution method, let's be coupled. Okay, and solution least square pressure, let's be second order upwind. Okay, now flow control momentum pressure, let's be 80. Let's be 0.5, 0.5, and I do equations, flow turbulence. Okay, if I go to advanced cycle stabilization, let's be P G 0 F cycle, also P G T, and F cycle P G C G T, and do OK, and go to limits. That's good. Okay, now we will go to monitor. If I go to resonance and print plot, if I see, okay. Now let's go to solution initialization and calculation and run calculation. Okay, number of iterations, let's be 1000. Solution initialization, just make it, or hybrid, it's hybrid is better. And then I will say initialize and wait for the initialization of the solution. Now the computer or the software is searching for the best appropriate starting point for the calculations. Okay, it will do 10 hybrid calculations. Initializing hybrid initialization method. Okay, initialization is done. Now I will go to save iteration. Okay, I will say to him calculate, and now the program is beginning calculations. This will take a while, so I will stop the record. The program is now calculating. As we see, this is a fast moving video. As we see, okay, now we will go to graphic setup, and to see the results we will choose what faces I need or surfaces I need to visualize. Okay, now I will see what axes or point or planes. I will choose planes, surfaces, and point and normal to make a new plane and visualize from its point of view. Okay, I now will make create. Now I will call it plane number 5, x, y, how much it's normal to what, or what is the circuit. Now I will select the point and a normal to it, and I will say create. As we will see, we'll go to contour and choose plane number 5, and we'll make display. That's the graphical animation that we will see. This is the how flow coincidence will be in the density of the flow, and where is the turbulence and the laminar regions. As we see, there is a laminar turbulence flow right here. It's circles and viscous circles that make so much diffusion on the body, because it's a holes and the fluid is going through the hole, so there will be some point behind this body that the turbulence flow will occur, and will make a vortex behind the system. So all what you see is the flow and the shape of the simulation flow, and you can do further simulation by adding, for example, a static structural solver, and see the effect on the body and the solid, and how the deformation and the stress and the strain will contribute. Now we will see the contour of turbulence. Now in the last one we see the contour of velocity and how the velocity will distribute, and where is the most speed and where is the less speed. Now we will see the turbulence flow, and when will be turbulence and when will be a laminar. As we see right here, there is a vortex behind the body, and where the beside the arcade. Okay, let's now go back to the velocity and see in a different method where the velocity is the highest. Okay, if we see the mesh and interior fluid, if we want to see the interior fluid contour and not the inlet or the outlet, or just the, and we'll uncheck fill, or let it check it. Let's see. Okay, now if I will make it more easiest to path lines, like path lines, it will be like arrows or a path lines shape. Maybe sometimes it's easier to see it in this way, because you can find where anything is. Now we will make save project and saving it. Now if I go to results and open CFD post processing, computer fluid dynamics post processing, as you see there is in fluid inlet, fluid outlet, and here are the 3D visualize. You can find the number of points. If you, there will be more steps. All when I increase the number, I will increase the density of the line, so I will increase the resolution of the view, and no more I will increase it until we find it satisfaction. Okay, so service streaming, not 3D screening. Look what will happen. Let's go back to 3D streaming and choose velocity and forward and apply. As we see, this is the contours of the velocity, streamlines from inlet to outlet, and how the diffusion will occur in the about the body or in the body. Okay. Now I'm changing the type of view so you can see. No, there is an error. Why is that error? Oh, because this must be fluid. Okay, the domain must be fluid. Now it's applying. Okay, let's play on the render and the view. Let's make it transaction. This is maybe easier to see. Okay, all fluid outlet and inlet. I choose the fluid I want to see. Okay, I can transparent it or untransparent it. Okay, I'll insert a button. Okay, I will make a new contour. The streamlines. Okay, as we see. Thank you and hope you find it helpful, and thank you for watching and hope it will be fruitful. And like this we do fluid analysis and fluid simulation in using Ansys workbench. Thank you for watching. Hope you find it helpful for you. Thank you. Goodbye.